is Maya and I'm a rising sophomore at Ramaz High School. So for my main project here at Milestone, I built a sun tracking solar panel with a wind-up clock drive, and I chose this project because I knew it involved a lot of mechanical engineering and I was very interested in that. So in order to do this, I had to draw a lot of schematics. So I chose to do this on a 3D modeling program called SketchUp. So this way I could figure out all the dimensions and everything and actually see my build from all angles before I even built it. So I divided this into two parts, the frame and the base. So after all the dimensions and the mechanical drawings were done, I got to work sawing the wood and building it and putting everything together. So my next step after that was to add the solar panel on the threaded rod and also to add the wind-up clock and make sure that the gears were meshing correctly. And this was very important. And I also added a moving sliding mechanism so that I could make the solar panel face the angle of the sun on any specific day. So I had a couple problems while making this. One was that the gears weren't meshing correctly at certain elevations because the frame of the solar panel wasn't very steady enough. So I added two triangular supports so that these two pieces of wood would be more perpendicular to each other, and that solved that problem. Another problem that I had was that the moving sliding mechanism held by shear friction on higher elevations, but once you put it on lower elevations, it just dropped. So I solved this problem by adding a friction wedge. And another problem that I had was that the solar panel rotated on its own and not on the threaded rod. So I basically just put epoxy on the wooden frames in the back, and then that held. So the way that the solar panel works is that it has photovoltaic cells in it, and the whole thing is made of semiconductive material like silicon. And when the energy from the sun hits it, it's converted to electrical energy with like electrons knocking out of the way and being forced through a certain direction by metal plates. And I wanted to see this power something real, so I created a circuit with an LED and a switch and a lead acid battery. So basically the energy goes from the sun to the solar panel through the solar panel controller, where you can see that it's charging. And then it goes to the switch, and then if I turn the switch on, the LED lights up. And if I turn the switch the other way, the power will go to charge the battery. So from this solar panel, I got around 12 to 13 volts, which is a lot, and that was more than enough to power my LED and my battery. So I had a lot of fun working at Milestone. I really enjoyed it. I learned a lot of useful things. I think that this project definitely ensured that if I were to go into a career in engineering, I would definitely choose mechanical because the results are very rewarding and the work is all worth it. So thank you.